Part 1. Why humans decided to build tunnels beneath the ocean. Have you ever been riding in a car or sitting on a train and suddenly found yourself traveling through a long tunnel? And then a strange thought popped into your head. How on earth did people build something like this? Now imagine that tunnel isn't under a mountain. It's under the sea. That idea sounds almost impossible at first. Most people think building a road on land is already difficult enough. You need to deal with rocks, unstable ground, weather, and massive construction challenges. But building a tunnel under the ocean takes those challenges to a completely different level. Because now you're not only fighting gravity and geology, you're also dealing with millions of tons of water sitting directly above your head. One small mistake could allow seawater to rush in with tremendous force. Yet despite the risks, humans have continued building underwater tunnels for decades. The reason is actually pretty simple. People have always wanted faster and more reliable ways to travel. Ships are useful, but rough weather can delay transportation. Strong waves can disrupt schedules. And as cities and countries grow, the demand for efficient connections keeps increasing. That's when engineers started asking a bold question. What if we could travel beneath the sea instead of across it? At first, many people thought the idea was completely unrealistic. The ocean seemed too powerful, too unpredictable, too dangerous. But history has shown that humans have a habit of turning impossible ideas into reality. We've built skyscrapers that touch the clouds. We've sent spacecraft beyond Earth. And eventually, we figured out how to build tunnels beneath entire seas. One of the most famous examples is the tunnel connecting England and France. Before it existed, travelers relied heavily on ships and airplanes. Today, trains can move passengers and cargo beneath the sea in a matter of minutes. What's amazing is that most passengers barely notice where they are. They're simply sitting comfortably in their seats. Meanwhile, millions of tons of seawater are directly above them. That alone makes underwater tunnels one of the most incredible engineering achievements ever created. But the real story becomes even more fascinating when we look at how they're actually built. Because it turns out that building an underwater tunnel is far more complicated than simply digging a giant hole. Part 2. The massive planning process before construction begins. When people think about construction projects, they usually imagine cranes, excavators, and workers wearing hard hats. But the most important part of an underwater tunnel project happens long before any digging starts. Everything begins with research. Engineers need to understand exactly what's hidden beneath the ocean floor. And that's not an easy task. Unlike a construction site on land, they can't simply walk around and inspect the area. Instead, they rely on advanced technology. Survey ships travel across the planned route. Special sonar equipment maps the shape of the seabed. Geologists collect samples of soil and rock from deep below the ocean floor. The goal is to understand exactly what materials lie ahead. This information is incredibly important. Digging through solid granite is completely different from digging through soft mud. A wrong assumption could lead to massive delays and huge cost overruns. In some cases, it could even force an entire project to stop. But geology isn't the only concern. Engineers also study ocean currents. They analyze weather patterns. They examine earthquake risks. And they investigate how the surrounding environment could affect the future tunnel. Think of it like a doctor performing a full medical examination before a major surgery. The more information available, the better the chances of success. Once enough data has been collected, engineers create detailed computer models. These digital simulations allow them to test countless scenarios. What happens during an earthquake? What happens if water pressure changes? What happens if unexpected ground movement occurs? Every possibility must be considered before construction begins. What's surprising is that planning can sometimes take longer than the actual construction itself. Some projects spend years gathering data and refining designs. That might sound excessive, but when a single mistake could cost billions of dollars and put lives at risk, careful preparation becomes absolutely essential. That's why underwater tunnels are not built on guesswork. They're built on years of research, testing, and precise engineering. Part 3. the giant machines that dig through the earth. Once planning is complete, the most exciting phase begins: the excavation process. But don't picture workers digging with shovels. Modern underwater tunnels are usually built using enormous machines called tunnel boring machines, or TBMs. These machines are engineering monsters. Some are hundreds of meters long, some weigh thousands of tons, and many look like giant metal worms crawling through the earth. At the front of the machine is a huge rotating cutter head. This cutter head is covered with powerful cutting tools designed to crush rock and soil. As the machine slowly moves forward, it chews through the ground one section at a time. The excavated material is carried away through conveyor systems. Meanwhile, something remarkable is happening behind the machine. Workers are installing massive concrete segments. These segments immediately form the tunnel walls. In other words, the tunnel is being built at the same time it's being dug. This process helps prevent the surrounding ground from collapsing. Modern TBMs are also incredibly precise. Advanced navigation systems constantly monitor the machine's position. If it starts drifting off course, operators can make corrections almost instantly. That's important because some tunnels stretch for dozens of kilometers, and sections excavated from opposite sides must eventually meet with extraordinary accuracy. Even a tiny error can create serious problems. Another challenge involves water pressure. Engineers often maintain special pressure conditions inside the machine to stop seawater from entering the excavation area. In certain situations, workers operate in environments similar to those experienced by deep-sea divers. Strict safety procedures are always in place. When people eventually travel through the finished tunnel, they usually see clean walls, bright lights, and smooth transportation systems. What they don't see is the giant machine that spent years slowly carving that path through the earth. Part 4. The underwater tunnel method that doesn't require digging. Here's something many people don't know. Not every underwater tunnel is created by digging through the ground. Some tunnels are built using a completely different approach. This technique is known as the immersed tunnel method. And honestly, it sounds almost unbelievable. Instead of excavating an entire tunnel underground, engineers first build giant tunnel sections on land. These sections are essentially enormous hollow concrete tubes. Each one can be hundreds of meters long. Once completed, the sections are sealed so they can float on water. They are then transported by ships to the construction site. Meanwhile, workers prepare a trench on the seabed. When everything is ready, the giant tunnel sections are slowly lowered into place. This operation requires incredible precision. Each section must connect perfectly with the next one. Even a small alignment error could create problems later. Once all sections are connected, engineers cover them with protective material. Eventually, the tunnel becomes part of the seabed itself. This method has several advantages. Since much of the construction takes place on land, engineers can work in a more controlled environment. It can also be faster and more cost-effective in certain situations. But that doesn't mean it's easy. Ocean currents, weather conditions, wave activity. All of these factors can affect installation. Sometimes engineers only have a short window of calm weather to perform critical operations. If conditions change unexpectedly, everything may need to be postponed. It's a powerful reminder that even with advanced technology, nature still plays a major role in every underwater construction project. Part 5. How engineers keep underwater tunnels safe. One question almost everyone asks is this: what happens if the tunnel leaks? It's a fair concern. After all, there is an entire ocean outside those walls. The answer lies in multiple layers of protection. Modern tunnel walls are made from extremely strong reinforced concrete. The joints between tunnel sections contain specialized waterproof seals. These materials are designed to remain flexible while resisting enormous water pressure. Engineers also install thousands of monitoring devices throughout the tunnel. These sensors continuously track movement, pressure, temperature, and structural conditions. If anything unusual happens, operators receive immediate warnings. Modern tunnels also include powerful pumping systems. If water enters the structure, pumps can remove it quickly. There are emergency exits, ventilation systems, fire suppression equipment, and evacuation procedures carefully designed for worst-case scenarios. Many of these safety systems were developed after studying lessons from past engineering failures. One of the strengths of modern engineering is its commitment to learning from mistakes. Every incident becomes valuable data. Every challenge improves future designs. As a result, underwater tunnels today are safer than most people realize. Despite existing in one of the harshest environments on Earth, they are designed to operate reliably for decades. And that reliability comes from thousands of engineers constantly asking one question: how can we make this even safer? Part 6. The future of underwater tunnels. At the end of the day, underwater tunnels are about much more than concrete, steel, and machinery. They're about connecting people. When two regions separated by water become linked by a tunnel, travel times can drop dramatically. Businesses can move goods faster. Tourism can grow. Economic opportunities can expand. And communities can become more connected than ever before. The tunnel linking England and France is a perfect example. Many people once believed it would never be completed. Today, millions of passengers use it every year. It has transformed transportation and strengthened economic ties between countries. And engineers aren't stopping there. Around the world, new tunnel projects are constantly being proposed. Some aim to be longer. Some aim to be deeper. Others are being designed to work with future high-speed transportation systems. These projects represent something bigger than engineering. They represent human ambition. Throughout history, people have repeatedly challenged what seemed impossible. Underwater tunnels are proof that determination, innovation, and scientific knowledge can overcome obstacles that once appeared insurmountable. So the next time you travel through an underwater tunnel, or watch a documentary about one, remember what's hidden behind those walls. Years of planning, gigantic machines, thousands of workers, countless engineering challenges, and one extraordinary goal: finding a way to connect the world beneath the sea. If you enjoy content like this, click the subscribe button and leave a like to support the channel, and share this video with friends who could use insights like these.